It's an assembly drawing. Why isn't it assembled? Supposing I wanted to cut an angle on this. Now, previously I ran through some methods of measuring angles, or how angles can be established. This one is a slightly more practical sort of problem. How do you do it? Well, one thing you can do, of course, is these vices typically come with a swivel base, and while I don't use one on here terribly often, I do have it stashed away somewhere so I can bolt it back on. So I could actually turn the mill round so that the material is held like that, and then I can just feed across there and put an angle on. Okay. If I wanted to put an angle on the top of this by feeding that way, I could use one of these. And this is the very reason I bought these, was that I can now come along, put that in there, snug that up against that, and I've got a 45-degree angle. If I needed more precision than I thought I was going to get out of this, I could get out my sine bar, put the sine bar on the side there, the appropriate stack. I could run an indicator off the column, and then if I had the right stack and the indicator said it was all level, I could assume that this was at 45 degrees, and so therefore if I do a straight cut, I was going to take that off, and that applies to other angles, to angles other than 45, of course. Another way of cutting angles on a mill is by tilting the head. This mill has only got, I can't even tell you what this axis is called, but it's only got this single axis. Some Bridgeports have also got a nodding function which will do that. I'm reluctant to do that in most cases. I have done it occasionally, but I'm reluctant to do that in most cases simply because tramming up a head is not a quick exercise. I mean, it can be if you're practiced at it, but it's a bit like the tailstock of your lathe. You can move it, but you're probably better off to think of other ways of doing things rather than just mucking around with changing the angle of the head, because you've then got to put it back again. This is the third way we have available to us on a mill, and that's a shaped cutter. These two are, well, that's a 60-degree dovetail cutter, and that's a 90-degree, it's actually a router cutter, router bit. But as well as working on timber, these work remarkably well, particularly on aluminium, even with the slow speed. And I'll be using one of these a little bit later on just to demonstrate. So that's always something if you're stuck. The other nice thing about router cutters is that they've got a whole bunch of radii for rounding things over. So if you're ever stuck for a rounding over cutter, particularly once again if you're doing aluminium, that's a worthwhile thing. I have had some people say that yes, I've used them on steel. I don't know whether I'm that brave, but see how we go. That's a dovetail cutter. 60 degrees. 60 degrees is a commonish sort of angle, but that doesn't mean there aren't other angles out there. I think the reason it is relatively common is that it's a nice angle for cast iron. Cast iron isn't all that strong in tension, and so it's nice to have a decent solid chunk of material sitting over the cutter, so that when the dovetails are in use, it's not trying to pull it out. One thing about dovetail cutters, of course, is that the ends of them are very, shall we say, delicate, and so you're better off doing a relieving cut with a standard end mill, and then just coming in and using your dovetail cutter the minimum amount possible just to clean up your dovetail. Don't make your feed too aggressive. You know, if you need to do a couple of passes, that's better than doing it in one pass and potentially breaking your cutter. There's the cut. It's not a bad cut. It's certainly smooth. The only trouble I have with using a pointed cutter like that one is that the tip of it is really not moving all that fast, and so if I were doing this in steel, I'd probably be more inclined, shall we say, to, pun unintended, to put my material on a 45-degree angle and then using a milling cutter, standard end mill, go along and cut. So try and get that the right camera angle there, and then cut the groove that way, because at least then the part of the cutter that's doing the work is moving at a decent speed. But other than that, they work. It produces a good cut, particularly in aluminium. I've had to use a bit of WD-40 to lubricate things. This is my preferred way of putting a right angle notch into a piece of material. Put the material at the appropriate angle, using whatever method you like, and then run through with a square and milling cutter. Run up to one mark first and then run down to the other one, as per normal milling practice, and that means the tip velocity stays much better, stays higher, much better cutting action, all that sort of thing to clear that out. People do also do this by milling a slot in there, and then using a cutter, on the theory, I guess, that if that corner isn't there, then it isn't going to cause you problems. But that's one way people do it. Here I am. I've got a small dovetail. I've got to get a dovetail shape in here. I've done a slight cut up here with a larger cutter that'll just clear that middle ridge. That's going to be turned into an angled piece in there. And that's just to take as much material out as I can before I have to cut with my small delicate cutter, which I'm going to be very apprehensive about using, but we'll use it nonetheless. Slow feed, lubricant, all that sort of fun stuff, and it should do it. One of the nice things about dovetail cutters is that they're set up properly. You can run them both in a pocket type dovetail as well as making the matching part. I'm going to set this up two ways. I want to put a flat on there, so I've got a 45-degree pip really. So using that little square thing that I showed you earlier, I'll put that in there and use that to set one, and then I'll use a combination square just to show that you don't need to necessarily have all these sorts of little gadgets and gizmos. So for a 45-degree angle, a combination square will do just as well, and you may find that if you only ever do 45-degree angles, you don't need anything more sophisticated. This is another way of getting angles on a mill. It's called a sine plate. It works on the same principle as a sine bar. You put gauge blocks, slip gauges, whatever you want to call them, Joe blocks, in there to jack it up to the appropriate angle, and that gives you a working surface which is however many degrees off flat that you want. And so here I'm making up some wedges. They're only 3 and a bit degrees, and so this just gives me that little bit of accuracy, I guess. If you want to get more than 45 degrees out of it, then you need to put an angle plate on there to lift that up. They generally only go into about 45 degrees or so.
A few ideas as to different ways that angles can be generated on a mill. Thanks to those who've inspired me, and we'll see you next time.